Now, I'm going to demonstrate how to do cylinder bore measurement with the help of a bore dial gauge.
The bore gauge consists of 1. Dial gauge of 0.01 mm accuracy. 2. Handle. 3. Centering contacts. 4. Measuring plunger. 5. Extension rod for various sizes. 6. Washers. Now, we are going to see how cylinder measurements are taken. First, check the actual size of the engine cylinder. Refer to the technical specifications of the engine service manual. There, you can see a chart containing the engine's exact specifications. If a service manual is not available, then use a ruler across the top of the cylinder to get a rough idea of its diameter. First, we need to set a micrometer to the actual size of the engine's cylinder. For example, suppose the actual size of the engine cylinder is 68 mm, then you set this value in the micrometer. Clamp the micrometer into a vise lightly. Select the correct size of the extension rod and set it in the measuring phases of the bore gauge. After adjusting the spindle to reflect your engine's cylinder size in the micrometer, place the curved frame of the tool inside the jaws of the table vise. Tighten the vise just enough to hold the micrometer still. You will be using the micrometer to transfer the measurements you take with your dial bore gauge. Fit a dial bore gauge with a head that matches the size of the cylinder. Zero your dial bore gauge to the micrometer. Position the gauge inside the micrometer with the head resting against the anvil. When you have identified this point, turn the face of the dial so that the needle is resting on the zero. Be prepared to pause and record your measurements as you take them. If you just want a rough estimate of the cylinder's bore, you can get away with making only 6 measurements, 3 at the top and 3 at the bottom.
If you also need to calculate its taper and outer front, keep in mind that you will need to create a new chart for each cylinder you measure.
Insert the dial bore gauge into the first cylinder in the block. Arrange the instrument so that the head points straight across the cylinder from front to back, perpendicular to the cylinder block. Lower it into the opening until it's sitting about 1.3 to 2.5 centimeters below the ridge. This will be the starting position for your first measurement. The measurement you take with the head of the gauge running perpendicularly to the cylinder block will be known as the vertical measurement. The one you take with the head configured parallel with the block will be known as the horizontal measurement. Rock the gauge back and forth until the indicator needle reverses its direction. Just like when you calibrated the dial bore gauge to the micrometer, the position at which the needle begins to fluctuate will serve as your measuring point. This occurs when the head is perfectly level inside the cylinder. Hold the gauge still at this sticking point and make a note of where the indicator needle falls on the dial. If the needle stops somewhere to the left of the zero, the measurement is in the negative range, which means that the cylinder's bore is greater than its clearance specification. Please note that no cylinder should ever have a diameter smaller than its listed dimensions, which would cause the needle to fall to the right of the zero. Translate and record the measurement you get in the first position. Each whole number on the dial represents 0.01 millimeters. Write down this measurement on your table. If the needle stops between the 7 and 8 positions on the dial, for example, it means that the inside of the cylinder is 0.07 and 0.08 mm larger than its clearance specification at your measuring point. Turn the head of the gauge 90 degrees and measure a second time. Continue measuring and lowering the gauge in 2.5 cm increments. When you found the overall bore of this cylinder, move your gauge over to the next one and repeat the process. Do this for each cylinder you want to measure. By the time you're done, you will be able to visualize the many small variations in width along the inside of each cylinder, which will help you decide what needs to be done to it. Compare the measurements of each of your cylinders to the dimensions listed in the engine's service manual. If any part of a cylinder's internal surface exceeds the minimum or maximum amount of clearance recommended for the piston, you may need to have it rebored. The major difference is obtained by subtracting higher reading to lower reading of ovality and taper. If the difference is more than 0.12 millimeters, then recommend replacing the cylinder liner and piston with a new one, or recommend for next oversized rebore if there is no cylinder liner used. Nowadays, almost all vehicles use cylinder liners. Record all the values measured in the table shown below. Based on the values obtained, decide the maximum taper and maximum ovality. Find out the maximum value in taper and ovality. If the maximum value is more than 0.12 millimeters, then decide to replace the cylinder liner and piston with a new one. In conventional vehicles, some manufacturers refer to reboring the cylinder also where cylinder liner is not used. In such a case, find out the maximum value of cylinder wear and multiply the maximum value by 2. For example, if the maximum wear is 0.08 mm, then multiply this value by 2. The answer will be 0.16 mm. In another case, the maximum wear is 0.14 mm, then multiply this value by 2 and the answer is 0.28 mm. Usually, the first rebored size is 0.25 mm. The second rebored size is 0.50 mm. The third rebored size is 0.75 mm. The fourth rebored size is 1.00 mm. Now, in the first case, the wear will be 0.16 mm, which is less than first oversize. So, recommend first oversize, that is 0.25 mm. In the second case, the wear will be 0.28 mm, which is more than the first oversize. So, recommend a second oversize, that is 0.50 mm. But the vehicles use cylinder liners. Recommend to replace the liner with the new standard size.
Thus, we have learned how to measure the cylinder bore and conclude. Hope you have clarity on this. Practice this exercise with the help of your instructor.